let's try an example. Let's minimize the function f of x comma y equals x squared plus y squared subject to the constraint 2x plus 3 equals 1. I'm sorry, this is a typo. This should be 2x plus 3y equals 1. I'll fix that when I upload the slides. So we're going to define the function g to be 2x plus 3y. Then the subject to part is g of x comma y equals 1 and fits the format of the method. So we should compute the gradient of f and the gradient of g. So 2x comma 2y for the gradient of f. 2 comma 3 for the gradient of g. And we need this to occur. We need gradient of f to equal lambda times gradient of g. So we have 2x comma 2y equals lambda times 2 comma 3. So we'll go ahead and push in that lambda, do the scalar multiplication on the right side. 2x comma 2y equals 2 lambda comma 3 lambda. So for these two vectors, 2x comma 2y and the vector 2 lambda comma 3 lambda to be equal, the corresponding components need to equal. So we'll set 2x equal to 2 lambda and set 2y equal to 3 lambda. And so from these equations, and the earlier equation 2x plus 3y equals 1, that's originally at the top, again, sorry for the typo, then we're going to have three equations and three unknowns. Right? The three unknowns are x, y, and lambda. So it's algebra time. So let's take these. So we've got three equations here, three unknowns. You can take these in a bunch of different orders. I'll go ahead and take the first equation, divide both sides by 2. X is equal to lambda. So we get real lucky that x and lambda they look like different variables, but they're always going to have the same value. Then since x is equal to lambda, we can turn 2y equals 3 lambda into 2y equals 3x. And then maybe solve for x here. So 2/3 y is equal to x. We'll substitute that in the last equation. So we'll have 2 times the x, which is now replaced with 2/3 y, plus 3y equals 1. All right, so we'll work that out and get y is equal to 3/13. And from the value y equals 3/13 and the fact that x should equal 2/3 y, we can get x is equal to 2/13. Since lambda is equal to x, we also can say that lambda is the same value as x, 2/13. Okay, the only solution we get is x is 2/13, y is 2/13, lambda is 2/13. So what we're going to do is now plug in that x and y value into the original function f. And I won't go through all the arithmetic here. If it looks all right, it should be 1/13. And since we only got one solution, this is the answer to the minimization problem. It seems a little strange. Why do we know it's a min? We're not going to, fuss through all of the details about that. We'll just say that, in some future problems, we will probably need to find we'll probably need to evaluate the f function more than once. So this is just a starting example.